All righty, welcome. So we have our gravity and orbits test coming up. So let's review. Okay, so first thing, a review on gravity. So a bunch of level 2 stuff. All of this is based off your gravity and orbits proficiency scale that is posted on Google Classroom along with this test review. So gravity is based on the mass and the distance. We have an equation for the force of gravity, and that's the gravitational constant, big G, times the mass of the first object times the mass of the second object, times the distance squared, the distance between the two masses squared. So you'll notice that it's based on mass and the distance. Everything that has mass has gravity. All things with mass attract all other things based on the force of gravity. But the further away they are, the greater the distance, the less the force of gravity and the acceleration of gravity is going to be. If there is less mass of the planet, there will be less acceleration due to gravity. Gravity is also the only force that's holding all objects to the Earth or to whatever planet they are nearest. That includes air, that includes the atmosphere. Magnetic field does not hold the atmosphere in place. The spinning of the Earth does not hold the atmosphere in place. It's just gravity holding things to the ground. Yeah. The atmosphere does not hold things to the ground. Only gravity is holding all of the things onto the Earth. Gravity is directed towards the center of the mass of the planet or towards the center of the mass of the object. So often that's also in the center of the object, like in the Earth, the center of mass is the center of the object. So the direction of gravity is always down to the center of the planet. But if something was not evenly densityed or evenly shaped, then it would be directed to the center of where the mass is. So if there's a denser part, it might be directed slightly towards that denser part. Gravity affects all objects that have mass, so literally everything in the universe that has mass. It's also modeled as from the center of the mass. So that's like we were talking here, directed towards the center of the mass, and it's modeled as if it's coming directly from that center point. So it doesn't matter how big the planet is. If it has the same mass, it's the same force of gravity to that center point. So if my mouth is the center of mass, then my head could grow twice as big with the same mass, and I would still have the same force of gravity directed towards the center of that mass. Gravity is not impacted by magnetism or by the Earth spinning. It's just by the mass and the distance between those masses, and gravity does not end at the atmosphere. It continues out indefinitely, although it decreases at an inverse square rate. Okay, orbits are the other piece on this test or quiz. Planets are kept in orbit due to their tangential velocity and the fact that the force of gravity is pulling them towards whatever they're orbiting around. So they are falling towards that object, but never getting any closer because of their tangential velocity. You could think of that tangential velocity as constantly flinging them outwards as the force of gravity is holding them inwards. And that keeps them going in a perfect circle. Actually, not a perfect circle, probably an ellipse, but close enough. For the force of gravity, we have our law of universal gravitation. That's the gravitational constant times the mass divided by the distance squared. That means that mass and force of gravity are directly proportional. An increase in mass is going to lead to an increase in force of gravity. It also means that distance and force of gravity are inversely proportional and inverse square proportional. So 1 over the distance squared leads to that much decrease in the force of gravity. If the distance increases 2 times, 2 squared is 4, force of gravity would go down by 4 times. If the distance gets 3 times further away, 1 over 3 squared is 1/9, gravity would go down by 9 times. If distance were to increase 4 times, 1 over 4 squared is 1/16, So gravity would decrease 16 times, et cetera, et cetera. If we make that bottom part, the distance, infinity, 1 over infinity squared is effectively 0. So if you can make the distance infinite, then there would not be any force of gravity. I mean, there still would be a little bit of force of gravity, but we could effectively treat it like 0. So to make no force of gravity, you would need to move those things infinitely far apart, increase the distance so much that they effectively don't interact with each other. There's also a little bit of solving. So solving scientific notation. Scientific notation, just to remind you, is a number times 10 to the power of something. So like 6.67 times 10 to the negative 11th, that's the gravitational constant. When solving scientific notation, multiply or divide the numbers, the 6.67 part, and then add or subtract the exponents. So for example, if I was doing 6.67 times 10 to the 11th, and then I was multiplying that by, let's say 3 times 10 to the third, I would multiply 6.67 times 3. That would give me about 20. Then I would add negative 11 plus 3. That would give me negative 8. So it would be 20 times 10 to the negative 8. But then I could move that one over. Since 20 is a 2-digit number, it could move over there, and it could be 2 times 10 to the negative 7th, for example. We'll be asked to solve some orbits. So you can solve for the orbital velocity using 2 pi r over t. That's a distance over time, where the distance is the circumference over the orbital period. You could also solve for the orbital period using 2 pi r over v, 2 pi r being the distance of the circumference divided by the orbital velocity. And then you're also going to be asked to solve for the force of gravity, just like you did in Model 5 or in the Chapter 12 practice problems, number 15, 17, 18, and 20. So you'll be given the mass of one object, the mass of the other object, the gravitational constant, and the distance between the objects. Remember to square that distance and then multiply and divide, and you're there. All right, best of luck on your test. I'm sure you are going to do wonderfully. If you'd like to review your chapter 12 and 14 questions, that's a good idea, or model number 4 and 5, also a good idea, probably model 5 especially. All right, best of luck, my friends.